In this lesson, we're going to be graphing quadratic functions that are in the form of f of x equals x squared plus k. Now, this all will lead up to when we have the general format of a quadratic, but we're going to start little by little. Okay, so key points. The graph of a quadratic function is called a parabola, right? So that is just, something like happy face, looking like that, okay? Where a cannot equal to 0 because then it will not be a quadratic. Then the vertex of the parabola is the lowest or highest point of the graph. In this case, this has a minimum, so the lowest point, that will be the vertex. The axis of symmetry is the vertical line that crosses through the vertex. So the axis of symmetry is the x value of the vertex. So it's a vertical line that crosses right through the middle of the graph. So let's see. The basic function of a quadratic is x squared. So f of x equals x squared. This is a home base. Home base, think about it like that, okay, is right in the middle. The vertex, which we'll be calling HK, the H represents the X and the K represents the Y. Right here, in this case, the vertex for this graph is 0, 0, where the X is 0 and the Y is 0. This is a happy face. If you notice, it's looking up, it's upward, so it's up. I always say happy face. Smiling, okay? So the axis of symmetry is the x value of the vertex. So in this case, x equals to 0 will be the axis of symmetry, okay? So based on the home base, every time I ask you to graph something, the first thing that needs to come up to your mind, if I'm dealing with, of course, a parabola, is the home base. The picture, so the image of the original graph should always pop in your head. And then based on the new equation that you're given, you're going to say, okay, what are the changes? Based on the original, what changed? If the original is f of x equals x squared, if something is added or subtracted, it means you're going to do an up or down shift, okay? And that's the first thing we're going to look, because we're looking at plus k. That means if you go at the addition, you're going to go up. If you go minus, you're going to go down, and that is a horizontal shift. Sorry, not horizontal, that's a vertical shift. Whoop. That is a vertical shift. Okay, vertical shift. So you're going to make a change in the y axis. So you're going to go up or down, okay? So let's see the examples. So I have, the directions are graph g of x equals x squared plus 1, right? So I'm thinking of the home base. So I'm going to start by drawing the home base graph. My home base looks something like that. Okay, no perfection, but at least I know it starts at the origin, right in the middle. Now, this has a plus 1. That means I've been added plus 1. So my new graph has to go up 1 from the original graph. So it's going to go up from 0 to 1. So now my lowest point is not going to be 0, 0. It's going to be 0, 1. So if you notice, the vertex here is 0, 0, but the vertex for the new graph is going to be 0, 1. So the y changed because you went up 1. Okay? Now, let's see. Another example. Again, the first thing that comes to my mind is the home base graph. The f of x equals x squared. This is the original. This is the one that I always picture. And then it says minus 2. That means I'm going to go down 2 in the y axis, okay? So my new graph is going to go down 2. So from here, I'm going to go 1 and 2. So now it's going to look like this. Okay? It's a bit wider. It's not supposed to be that wide. I'm just not the best drawer in the world. Or just not that good drawer. Whoop, there. Whoop, there. Perfect. If you notice, the vertex for the old one is 0, 0. But the vertex for the new one is 0, -2. Okay? So now the minimum value has changed for the graph. So let me just make sure you know that which one is the new one. This is the new graph. Okay? And for the other example, again, the brown one is the new graph. Okay? Always good. So those were 2 examples that showed you how a quadratic graph looks when it's in this format right over here.